Suppose I've got an equation and we're looking at normals, and I get asked to find the equation of the normal at a certain point. Let's say at 2, 3, given the function f of x equals, let's say, 3x cubed minus 4x plus 1. A random equation, random point, and I want to find the normal. The steps behind this, if we have to put it in steps, I mean, we could do that. The first thing I'm going to do is derive the function. So I'm going to go ahead and say find f of x, step 1. Once I've found f of x, then in order to find the equation of the normal, this, remember, is the gradient. I'm going to take the 2 from the coordinate, which is x is equal to 2, and I'm going to substitute it into the equation there, because that will then give me the gradient, and the solution of this will go into y equals mx plus c if I need the tangent. But before I even need the tangent, because it's not asking for it, I can go straight from there and get negative 1 over m and put that inside the normal equation. And once I have that, I then substitute that same point 2, 3, because at any point in time, if I got a tangent and a normal, they will share that point of intersection, in which case I can substitute 2, 3 into both equations to find c. And I would sub that there, get c, and then I'm done. Okay, let's do that. So step 1, let's derive it. I get 9x squared minus 4. Step 2, I'm going to substitute x equals to 2, straight from the question, into the derivative. That becomes 9 times 2 squared minus 4, which is 36 minus 4, which is 32. And I've got this derivative now, which is quite a steep gradient. So I know that the normal gradient, because this is the tangent's gradient, this is aligned to the curve. At that point, aligned to the curve will be the tangent gradient equal to 32. So the normal gradient, which is 90 degrees, is going to be negative 1 over 32. So we flip the sign, we make it negative, find a reciprocal, make it negative. And then we substitute. After substituting now 2, 3, we can get c in there. All right, so we get 3 equals negative 1 over 32 times 2 plus c. That becomes 3 plus 1 over 16 is equal to c. And it can be 16 times 3 is 48 plus 1 is 49 over 16. So therefore, negative 1 over 32x plus 16 times 3 is 48 over 16. Yeah. And that's the equation of the normal. Done. Okay. Keeping that in mind, let's see if you can try one now. Okay. All right. So find the equation of the normal, keeping in mind the steps. Step 1, derivative. Step 2, whatever x value you get, put it in there, get some m value. Step 3, negative 1 over m, and put it into the equation y equals negative 1 over mx plus c, and substitute the given point. Okay, find the equation of the normal of the curve y equals negative 9x squared plus 4x at x equals to 3. Or let's say at the point 3, 2. Well, obviously this curve has to have the 0.32 line on it. So ideally, at x equals to 3 means that you have to find the corresponding y value. Okay. Press pause, try it. When you're done, press play. We're going to trace back after this and go fix the previous question because we should have provided the x value only and then obtain the corresponding or perfect y value, because the previous question I suggested a random point, but that point actually did not lie on the curve. All right, but we'll go back in a bit. All right, so to calculate the solution, we're starting off by finding the derivative. Now I can also find the y value. If I make this 3 and I make that 3, I can just go ahead and get the corresponding y value. And that's what happened in the previous question, is that we were given a random y value, but if you substitute 2 into this equation, it doesn't actually give you that 3. All right, so 3 is going to go into the 3 squared, which will get you 9. 9 times 9 is 81. So negative 81 plus 12 comes to negative 81 plus 12 comes to negative 69. 3 goes into the 9. Negative 18, negative 81 plus 12, yeah, negative 69. Okay, so that's the point, just to keep it in mind as we go along. Let's go to step 1. The derivative is going to be negative 18x plus 4. I'm going to substitute in step 2 now, x equals to 3. That's going to get me negative 18 times 3 plus 4, which is negative 54 plus 4, yeah, negative 50. That's right. And therefore, that's going to be the gradient of the tangent. The gradient of the tangent times the gradient of the normal is equal to negative 1, basically. So that's actually a formula you can think about that. Negative 50, so like you got there, 1 over 50 is correct. So therefore, step 3 now, obtaining the 1 over 50, putting x in front, plus c. I'm now substituting a point, 3 and negative 69 in there. And that gets me negative 69 equals 1 over 50 times 3 plus c. So negative 69 minus 3 over 50 equals c, and that's negative 69 and 3 over 50. So that's right. So that's your final equation. All done and dusted. Let's go back and fix this question up now. So there's an area because of that 3 being there. So I'm going to change this question. I'm going to say at x equals to 2. And then we're going to replace all of this with a new calculation. All right. Press pause, try it. When you're done, press play. All right, suggested solution, y equals negative 1 over 32, x plus 17 and 1 over 16. All right, deriving it, we had 9x squared minus 4. Deriving it at x equals to 2 gets us 9 times 2 squared minus 4, which is 4 times 36 minus 4, which is 32. Therefore, the gradient of the normal is going to be equal to negative 1 over 32. So y equals negative 1 over 32 x plus c. By changing this value into 2, gets us the x value to become 2. That'll become 3 times 2 cubed minus 4 times 2 plus 1, which becomes 17. And it looks like we're on the right track there. We then substitute that into the equation, and we get 17 equals negative 1 over 32 times 2 plus c. So 17 plus 2 over 32 equals c. 17 and 2 over 32, which is the same as 17 and 1 over 16, is equal to c. So that's correct. Final answer. Done. Remember that the concept of having an equation which is a cubic function, at some point you can have a cubic function that does this. And there is a possibility that if you have a tangent, that tangent exact same line can be parallel in a different place. So you can have two parallel tangents. And because you have two parallel tangents, you will have two parallel normals as well. So just write this, make this a little bit parallel. So let's say this is parallel. It will end up there somewhere. The normal will also be parallel to each other. And there'll be two of them as well. So there'll be one over here, and there'll be one over here. So two normals, and this would be for a cubic function. And this can be applied across a x and y axis. Let's just say randomly that is what the curve actually is. If that's the curve, then we know we have x-intercepts for the cubic function and y-intercepts for the cubic function. And the parallel lines can then be given. So I could give you a point. I could give you the x value for this here, let's say. And I'll ask you to find, so I'll ask you to find this tangent given the equation, question 1. And I'd ask you to find this normal in question 2 in a separate question. So given the equation is, let's say, y equals 3, let's say 3x cubed plus 6x plus 4, say 6x squared plus 4x minus, say, plus 4, let's make it minus 4. Let's just suppose that's a random equation. Then I can derive this function, change x into 2, get the gradient, substitute this back in there, get the y value at that point. Once I've got that coordinate, substitute it to get this tangent. Take this tangent, inverse it, and also remember that I can get two values for this. So I've got to now use a parallel line formula, and this is going to have exactly the same gradient. So if this gradient ends up as, let's say, some b, then this is also going to be bx plus some other c, which ends up over here cutting the y-axis. So just an idea of a question to keep in mind, possibility of bringing in parallel lines with two tangents that can exist. Two tangents can also exist in a circle. So if you have a circle, you can have a tangent there, and you can have exactly the same parallel tangent on the other side when dealing with parallel lines. There's lots of other questions, obviously, around that, but yeah, that's one of just an idea.